So solving a 3x3 system of linear equations, problem type number 2, on the ALEKS homework topic for this week. Solving the system of equation using substitution method, not a elimination method. Not that we can't solve this using elimination. I guess we can. Absolutely, right? But just wanted to show you a different method. It's called substitution method. What I will do is I will solve one of these 3 equations for a one letter. Like either I want x equals, whoopsies, it's a dotted line pen. Give me 1 second. Either I want x equals la 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 la, whatever's on the right side, or y equals something else, or z equals something else. See, if I can solve one of the equations in this format, I'll be able to substitute what's on the other side, what's on the right side of the equal sign, in for one of these variables. So I want to do a substitution method. So I'm going to look at these 3 equations that's up here. Okay, one of them looks very easy to work with. If you take a look at the middle equation, you see how we can just add 3z. We can just add 3z to both sides and get y equals, give me 1 second, let me write that down. Y equals positive 3z plus 9, right? Because 9 was a positive number, so that's going to be plus 9. So I just rewrote the second equation so that is solved for y. Why did I do that? I can plug in what's on the right side of this equal sign as y. 3z plus 9 is equal to y. So I'm going to substitute this 3z plus 9, which is a binomial, right in here, okay? So let's write down equation number 3, the very bottom equation with substitution, okay? So that will be 3, whoopsie, that will be 3. Instead of y, what do we want to put in there? Instead of y, we're going to put in 3z plus 9. Keep going. Luna. You want to play with the cat? All right. Minus 2z, I'm just copying the rest of that equation, equals 13. Okay? So, after doing the substitution, oh, my handwriting is a mess. Give me 1 second. Let me fix this up a little bit. 2z equals 13. I'm going to solve this for z. I'm going to solve this for z because z is the only variable in here now. Okay? So let's distribute. Let's distribute the 3 outside. Okay? So I'll get, give me 1 second. Let me write it down. 3 times 3z will give me 9z. Okay. 9z plus 3 times 9, I'll get 27 minus 2z equals 13. Okay? Now, let's combine the like terms, the ones with the z's. If I add 9z plus negative 2z, you agree with me that is 7z, right? 7z plus 27 equals 13. To solve this for z, I will subtract 27 from both sides. And if I figure out what 13 minus 27 is, that is negative 14. How perfect! Because now all I need to do is divide both sides by 7. And if I divide both sides by 7, I will get z equals negative 2. I'll circle this because this is going to help us find the second variable. Okay, so let's go now and find y. Using y equals 3z plus 9, that very first equation we got from rewriting the second equation, we can find what y is. So let's do the substitution again. Y equals 3 times z plus 9, which is -6 plus 9. So we got that y is actually equal to 3. So we have what y is, and we have what z is. All we need to find is the x value. We only use the middle equation and the bottom equation, right? Number 2 and number 3. We didn't even use the first one. So this is time for us to use that first equation, which is x minus 4y plus z equals -16. We're going to use that red highlighted equation to find what x is. Because guess what? We know what y is and we know what z is. The only thing that we don't know is the x value. So, it will be, well, I'll go ahead and write down what I'm doing here. Plug in y equals 3 and z equals -2 into equation number 1. And I didn't even name my equations in this problem. That's what I mean by equation number 1, the one in red. That first equation on top. So let's do the substitution then. I will get x minus 4 times 3 plus -2 equals -16. So I did my substitution and I need to simplify this equation now. Turns into x minus 12, another -2, that equals -16. So x minus 14, subtracting 12 and subtracting 2, so that's subtracting 14, that equals -16. And if I add 14 to both sides, plus 14, plus 14, I'll get my final answer. X equals -2. So I'm going to circle it, and I'll go ahead and scroll up and write down that the solution is x equals -2, y equals 3, and z equals -2. You can write this solution as an ordered pair. I said it wrong, right? It's not an ordered pair, it's triple. So I should say ordered triple in this format. And because this is a unique point, okay, this system is considered consistent, independent. Okay, so that's it. That's it for this example. I'm gonna go, this was shorter than the first one. I'm gonna go ahead and process this video and put it on Canvas for you.